AI videos usually stop at just 10 seconds, way too short for a moral story. But with Google Veo 3.1's extend feature and this n8n automation I built, you can now turn simple text prompts into complete story videos automatically. Here is how this works. We fetch video prompts from Google Sheets, generate the first video scene using Veo 3.1, wait for it to process, update the sheet with completed video URL and task ID, then automatically extend that video with next scene. Repeat this extension process for each subsequent scene in your story, and finally merge all the scenes into one seamless video. To make all this super easy, I have created a complete workflow template for you. You can grab it for free from my Skool community. Link is in the description. Once you join, download the JSON file. Then in n8n, click the plus sign, select the workflow option, hit the three dots here and choose import from file option. Select the template and you will have the full workflow imported instantly. You will also need to copy the Google Sheet template. Here is the simple Google Sheet template with just 4 columns. You just need to fill the video prompt with the scenes you want generated and mark those rows as pending in the status column. That's all you need to do here. Now let us walk through the workflow. I have divided the workflow into 4 sections for easier organization. First is the input, then we have generate video, then we have extend video, and then we have merge videos. The workflow starts with this manual trigger. Just click this execute workflow button and the entire story generation process begins. Next is this Google Sheets node that fetches the first video scene that needs to be generated. You will need to enter your Google Sheet credentials here. You can refer to the link in the video description for a quick step-by-step guide on setting up Google Sheet credentials. We are connecting to Veo 3.1 extend worksheet and looking at this use cases sheet. The filter here looks for rows where status equals pending. This means we are only grabbing videos that haven't been created yet. Here we turned on this option, return only first matching row. So we process one video at a time rather than batching. Each row fetched here contains your video prompt, which is the scene description, and task ID, which we will populate later for the extensions, status, and the output column where the final URL will be updated. This node grabs the first scene prompt and passes it forward for video generation. Great, now we have got our first scene ready to generate. Next up, we will submit it to the AI. This HTTP request node sends your first video prompt to Key AI's Veo 3.1 video generation endpoint. You will need Key AI credentials. Sign up at Key AI. Then once you log in, you will need to add a small balance like $5 to your account that will give you 1000 credits. Then navigate to the API key option here and generate an API key. Once you have those details in n8n under authentication, select generic credential type. Then in generic auth type, select header auth, and in this header auth field, click on the drop down box and select create new credential option. Then type authorization under this name field, and in the value field, type in the word bearer followed by space and then paste your API key here. Then click on this save button. You will need to set up this credential only for the first time. Now let us quickly go through the Veo 3.1 video creation API endpoints. Again, when you are logged in to Key AI, select API market here, scroll down, and then you will find this Veo 3.1 card. Select that one and it will display details about the Veo 3.1. Here you can see details about the Veo 3.1. In the playground, you can type in your prompt and then see how the video gets generated here. It will show you here how many credits will be consumed for generating that video. But we are interested in using the API. Select this API button. Here you can see the API details. Here is the video generation API. We have full details about the API here. You can go through this documentation. Here is an example on how to use this API using curl request. Here is the API endpoint URL, and this is the method that we need to use. Now let us switch back to n8n. We are using the same post method here, and we are using the same URL that we just saw here. And here is the JSON body. The prompt field pulls directly from your Google Sheets video prompt column. Here we are using the Veo 3 fast model, and aspect ratio is set 16:9, perfect for YouTube. Enable translation is false since we are working with English prompts, and generation type is text to video because we are creating the videos from text only. Once submitted, the API returns a task ID that we will use to track generation progress. Okay, now the video is submitted. We will wait for the AI to work its magic. We need to give the AI time to generate your video. This wait node pauses for 1 minute. After the pause, we will check if the video is ready. This HTTP request node calls the VO 3.1 record info endpoint to see if the generation is complete. Here we are using the method get, and this is the API endpoint URL. Let us quickly look at this API call details on Key AI website. We are using this get VO 3.1 video details API. Select this API and all the details belonging to that API will be displayed here. Here is the curl example of the request. The method is get, and this is the URL for this API call. Here it can return different statuses. Status 0 means the task is still being processed, and 1 means task completed successfully, meaning video is generated. Any other value means the video was not generated successfully. Let us switch back to n8n. We are sending this query parameter task ID, whose value will be populated from the previous submit video node. The response from this API includes a success flag field that tells us everything. As we have seen just now in the API call details, 1 means success, video is done, 0 means still processing, and anything greater than 1 indicates an error. This status flows into the next node to decide what happens next. This is our decision maker for the generation process. Based on the success flag value, we route the workflow different ways. Here we are saying if it is equal to 1, mark it as success, and if the value is 0, mark it as in progress. If it is greater than 1, mark it as error. If it equals 1, we take this success path. If it is equal to 0, we take this in progress path. The video needs more time, so we will wait 30 more seconds. If success flag is greater than 1, we take this error path. So we are not handling the error here. So failed videos will just stop the workflow. When the switch determines the video is still cooking, we land here. This wait node pauses for 30 seconds before checking again. After this pause, it loops back to retrieve generate node to check the status again. This creates a polling loop that keeps checking every 30 seconds until success or error. Next, we will see what happens when the video is finally ready. When the generation succeeds, this Google Sheet node updates your spreadsheet with the results. We are updating the sheet matching records by this row number. The status column is updated to done, so you know this scene is complete. The output column gets updated with the video URL. Here is something clever happening. This node updates the next row in your spreadsheet with the task ID we just received. The row number is calculated as the current row plus 1. So we are moving to the next scene. The task ID field gets populated with the response task ID from the retrieve generate node. Can you guess why we are doing this? Because to extend a video, VO 3.1 needs the task ID of the video you are extending from. So we are automatically preparing the next row with the information it needs to continue the story. This creates a chain where each completed video enables the next extension. Alright, first scene video is done. Now let us see if there are more scenes to extend. This Google Sheet node checks if there is another scene waiting to be processed. The filter looks for status equals pending again, and return only first matching row is turned on. But here is the key. The always output data option is enabled here. We can see that in the settings option. Here is the toggle that you can switch on, switch off. What this means is even if no pending rows are found, this node still passes an empty result rather than stopping the entire workflow. This is necessary because when all the scenes are done, we want to merge videos in the workflow. If we don't turn on this setting, the workflow will stop right here at this node once all scenes are generated. This conditional node checks whether we found any more scenes to generate. This condition evaluates whether the getExtend node returned 0 items. If getExtend node found rows, we take this false output path and continue to submit extend node, meaning there is more story to tell. If getExtend returns 0, we take this true output and jump to merging all videos, indicating the story is complete. This decision point is crucial for creating stories of any length without hard coding the number of scenes. Next up, let us see how video extension works. This HTTP request node calls key AI's VO 3.1 extend API endpoint. Let us quickly review the extend API call. Select this extend VO 3.1 AI video option here. Here we can see the details about this API call. Here we can see the curl example on how to use this extend video API call. We use the post method and this is the URL for the API endpoint. As you can see, it requires only two parameters. One is the task ID and other is the prompt. In the prompt, you tell what happens next as continuation of the video, and the task ID belongs to the original video which you want to extend. Now let us switch back to n8n. We are using the same post method and then the same URL for the extend API. In the JSON body, we specified the task ID that comes from your current rows task ID column, which was populated by the previous video's completion. And this prompt is the new scene description from your video prompt column. Let me show you the Google Sheet to illustrate this point. Let us say, for example, we have completed this first scene. So this output column will be updated with the video URL of the first scene, and the task ID for the next scene will be updated. Then when the extend API node runs, it will take this task ID and this prompt to generate new video as an extension to the first scene, and it will update the new video's URL in this column. This tells VO 3.1 to analyze the ending of the previous video and generate new footage that smoothly continues from where it left off. The AI matches the visual style, lighting, camera angle, and overall aesthetic to create a seamless transition. Once submitted, we get a new task ID for tracking this extension's progress. These next 4 nodes are similar to what we already covered earlier in the generate video section. This node sets up the next scene for extension. When extension succeeds, this node updates your Google Sheet with the results. This is similar to the update video generation node that we have seen earlier, where matching by row number and status is updated to done, and the output field is set to the video URL. This marks the current extension as complete and provides the URL for the extended video. But we are not done yet. We need to prepare the next extension also. This node sets up the next scene for extension. Again, the row number is set to current row +1, moving to the next scene in sequence. The task ID field gets populated with the task ID from the retrieve extend node's response. This chains the extensions together. Each completed extension enables the next one by providing its task ID. After updating the spreadsheet, the workflow loops back to the getExtend node to check if there is another pending scene. This creates an automatic loop that processes every scene in your story until they're all done. Once all scenes are complete, we move to merging. When all scenes are done, this Google Sheets node fetches every completed video URL. The filter looks for status column equals done value, only grabbing successfully generated and extended videos. This gives us a complete list of video URLs in the order they were created, ready to be merged into one story. This aggregate node prepares our video URLs for the merge API. We are using this to combine multiple rows into a single object. Here we have specified all items into a single list and put everything in the output field called data. This includes setting specifies we only want the output field, that is where our video URLs live. This transforms multiple rows of data into one clean array of video URLs that the merge API can consume. Here is where we stitch everything together. This HTTP request node calls fal AI's FFmpeg merge videos endpoint. You will need fal AI credentials. Sign up at fal AI. Once you're logged in to your fal AI account, select this manage option, then select API keys and create your API key and also add some balance to your account. Let us switch back to n8n. Once you have the API key details, under authentication, select generic credential type. Under generic auth type, select header auth. Under header auth, click on this drop down box and select create new credential. Then under the name field, type in authorization. Then in the value field, type in the word key with a capital K followed by space and then paste your API key. Then hit this save button. Now let us quickly review the API endpoints we will use. While you are in your fal account, click in this search box and type in FFmpeg and select this video to video option. Here we can see details about the merge video. Select this API option. Here it will have all the details on how to submit a request, how to fetch the request status, and then how to get the result. Let us select this submit a request option. Here you can see a curl example for this submit request API call. We will be using post request and this is the URL that we need to be using. Here we have specified the same details. The body parameter video underscore URLs takes the aggregated output array from the previous node. This expression here maps over the data array to extract just the output URLs. Fal AI's merge service takes these videos and concatenates them in the order, creating one seamless story video. This API returns a request ID that we will use to track the merge progress. The merge has been submitted now. We need to wait to see if it is done. We wait here for 30 seconds. The video merging takes some time as the service needs to download all your individual videos, concatenate them, re-encode the output and upload the result. We give it half a minute before checking status for the first time. This HTTP request node checks if the merge is complete. Let us take a quick look at this API call. Here you can see fetch request status API call details. We will be using get method with this URL. The request ID will be filled from the previous node. The response from this API includes a status field that tells us if the merge is completed or in progress. This status flows to the next switch node to decide what happens next. This routes the workflow based on the merge status. Here, if the status returns completed, we will name it as done. If it returns in progress, we will name it as in progress. If the merging completes, we take this done output. The merged video is ready to download. If status equals to in progress, we take this output as we need to wait more. We will wait for 15 more seconds here before checking again. We use shorter wait interval because merges typically complete faster than individual video generations. After this pause, it loops back to check the status again. This continues until the merge is complete. When the merge is done, this HTTP request node downloads the final merged video URL. Let us quickly look at this API endpoint. This is get the result API endpoint details. Here we are using the get method and this is the URL of the endpoint. Here we populated with the same URL. The API response includes the URL to your completed merged story video. You can now download it, share it, or upload it directly to YouTube. And that's it. You have just automated the entire moral story video creation process from first scene to final product. Now let us talk about Google Sheet setup. Your Google Sheet has these 4 columns: video prompt, the scene description for each scene, then the task ID. You can just leave it empty. Then the status column, set the value to pending for all the scenes that you want to generate. Then the output column, leave it empty. You can even ask ChatGPT to provide you a moral story with the number of scenes you want and the animal character you want for the story. You can also tell the theme of the moral story. The theme can be of courage or patience or kindness. Once you get the output from ChatGPT, you can simply paste them into this video prompt column and you're good to go. Let us see this in action. We already populated our Google Sheet with the moral story scene prompts. Click this execute workflow button to start. We can see the workflow is running. It will take a while to complete because it needs to generate 5 scenes. Once the workflow completes, check your Google Sheet for all the individual video URLs. You have just created a complete moral story video with zero manual intervention. Now you can scale this to create hundreds of stories automatically and then post them to your social media account. The workflow has finished successfully. Here is the video URL that it generated. Let us take a look at the generated video.
No beast can match my power or my voice. What happened to my voice?
I never thought silence could be louder than my roar.
I've been roaring for so long, I forgot how to listen. A true king doesn't need to roar to be heard.